Networks Lesson 5 Protocols and Domain Name Servers.
So a bit to recap from previous weeks, the advantages of networking. So users can share files, share peripherals such as printers. Remember we said that if you weren't on a network and you were in a school classroom and you wanted to print, each and every machine would need a printer, or you would have to have one printer set up in the room attached to one of the computers, and then you'd have to move around. So you can see that that is a clear and definite benefit to networking. Some others there, so servers can control the security, the software updates and backing up of your data. You don't need to worry about that. Don't need to go over all of them again, you can read them. Disadvantages of networking, so increased security risk to data. There's obviously malware and viruses can spread easily. If a piece of equipment like a server fails, then all of the computers on the site may not work. And obviously they can be expensive to set up and maintain, and you need a bit of technical know-how, which is why obviously the school employs technicians to look after hours. From last week's, a few of the pieces of hardware you need to be aware of. So wireless access points, sometimes shortened to a WAP. They provide wireless access to a LAN. A router connects a LAN to a WAN. A switch sends data between computers on a LAN. A NIC, if you remember, is your network card, so allows you to connect an Ethernet cable to your computer. And then transmission media is the posh name for how that data has been transferred, so whether it be Ethernet or fibre optic.
There are also a number of factors that can affect the performance of the network. In other words, how fast you can download and receive data, or indeed upload data. These performance factors of networks include the bandwidth. This is your overall speed of your network. Imagine the bandwidth as being how many lanes there are on a road. The more lanes there are on the road, the more traffic can go down that road at any one time. The higher your bandwidth on your network, the more data that you're able to send or receive at any particular time. Another factor that can affect the performance of your network is the number of users. The more people that are using the same network, the slower that network will be. You might see this at home if you have multiple family members trying to access video streaming services at the same time. You'll see perhaps an increase in the amount of buffering that takes place. Another factor is the error rate. When data is sent across a network, some of that data may get corrupted or go missing. This is the error rate, which may mean that data needs to be sent again, slowing the network down. You should also consider the transmission medium. For instance, a wireless network, while more convenient, will usually be slower than a wired network, and a fibre optic network is much faster than any other type of network. And finally, latency. Latency is the delay between sending a request for data and the server responding with the data that you have requested. So the performance factors that can affect a network are the bandwidth, the number of users, the error rate, the transmission medium being used, and the latency. So let's take a look at how a computer would access and find a web page that we're looking for. Let's suppose in this example that we wish to access the BBC News website. We'd first of all load our web browser, and then having loaded the web browser, we would type in the address for this page. In this case, it would be https://www.bbc.co.uk/news. Now, if we break this down, this is what we call a URL, or a Uniform Resource Locator. And it's made up of several parts. The first part here, HTTPS, is the protocol that we're using. And the protocols are the rules that computers can use to help access documents and files. We then type in the www, and this indicates that what we're accessing is in fact a web page. We then type in the domain name, in this case bbc.co.uk, and then we type in the folder that we want to access. In this case, we want to access the folder containing the news. This is the URL. So let's take a deeper look at what we mean by domain name and introduce something else new called an IP address. So let's suppose that you want to phone somebody or send them a text message. Do you actually remember their telephone number? I would probably hazard a guess that you don't remember their telephone number. And that what you do is you simply look for their name in the phone book, in the contacts on your mobile phone, and then that tells you what their phone number is. So you don't have to remember a long series of digits. You just look up their name in your contacts, and that gives you their associated telephone number. Well, something similar happens with the computers, because every device on the network has what we call an IP address, or an Internet Protocol address. And an IP address is just a series of 4 8-bit numbers. Here's an example: 38.160.150.31. And this is a number that will uniquely identify a specific device on the internet. However, because just like phone numbers, IP addresses are difficult to remember, we can substitute these for what we call a domain name. And the domain name is a more human-friendly form of the IP address. In this case, the IP address that we've been looking at, 38.160.150.31, is actually for the domain name bbc.co.uk. So the IP address is a series of 4 8-bit numbers, and the domain name is a human-friendly version of that IP address. So, what can a domain name actually tell you? Well, a domain name can tell you some useful things about the web page that you're trying to access. Let's take a look at the following domain names and see if we can work out something useful about them. Here we've got Amazon.com. Usually if a website ends .com, it's telling us that it's American. Might not always be the case, but often it indicates that it's some form of American company. .co.uk, well, the UK part here tells us that it's within the United Kingdom, and the .co part tells us that it's a company. So Amazon.co.uk is a company within the United Kingdom. Amazon.de, the .de tells us that this website is based in Germany, DE for Deutschland. And the last one here, Amazon.nl, the NL is short for Netherlands. And these .com, .uk, .de and .nl are what we call the top level domains. They often indicate the country that this website originates from. So let's take a look at some more examples of domain names. Here we've got staffs.ac.uk. The AC tells us that it's a university, an academic institution, AC for academic, and of course UK indicates it's based in the United Kingdom. .gov.uk, well, the gov here is short for government. So this is telling us that stoke.gov.uk is a government-based website in the UK. This address here, .staffs, well, that's telling us it's Staffordshire, and the .sch is short for school. So this is telling us that Moorside is a school in Staffordshire in the UK. And finally, this one here, .edu, is telling us that this website is a university in America. There are lots of other domain names and top-level domains which you might want to look up and you might want to look up to see what they are. So let's take this opportunity here to just pause for thought and ask yourself, can you explain what a URL is, what a Uniform Resource Locator is? Can you explain the difference between an IP address and a domain name? And can you give an example of an IP address and a domain name? If you can't, before you progress with this video, I suggest you go back and you review some of the previous slides. So now let's take a more detailed look at how the computer resolves the domain name with the IP address. So remember we said that computers use IP addresses, not domain names. So the BBC's IP address is 38.160.140.31, and that represents the domain name bbc.co.uk. But as we previously said, human beings are not very good at remembering long sequences of numbers. So when we want to access the BBC's website, we simply type bbc.co.uk, the domain name, into our web browser. Somehow the computer then has to locate that particular website by finding out what its IP address is. So how does the computer find the IP address when you type in a domain name? Well, let's assume that this represents our web browser, and we're going to access that BBC website. So we type in the full domain name www.bbc.co.uk. What then happens? Well, on the internet there are a series of machines. These machines are called DNSs, or domain name servers. And these DNSs are devices on the internet that act almost like the internet's telephone directory. So when you type in www.bbc.co.uk into your web browser, the first thing that your web browser does is it establishes a connection to a domain name server. And it asks that domain name server for the IP address of bbc.co.uk. The DNS will search through its database, will look for the domain name bbc.co.uk and find the associated IP address. It will then return this IP address to your web browser. So your web browser has made a query to the DNS. What is the IP address for bbc.co.uk? The DNS has then looked up that domain name and returned the IP address to your web browser. So now your web browser has that IP address. It can then establish a connection to a web server. It can request from that web server the page with the IP address 38.160.150.31. This is then returned to your web browser. Your web browser can now display the web page. So in summary, how does a domain name server work? Well, the first stage is the user types in the domain name, e.g. bbc.co.uk. A connection is then made to the domain name server to request the IP address for the required domain name. The DNS looks up the domain name and finds the IP address. The IP address is returned to your web browser, and the web browser can then use the IP address to access the website. So this would be another good point to just pause for thought and make sure that you understand what was on the previous slides. Can you explain what a DNS is and what the letters stand for? Can you describe how a DNS is used to access a website? If not, go back to the previous slides and review the material again before you continue. Something that we mentioned briefly when we were looking at the makeup of a URL is we introduced this word called protocols. It'd be worth spending some time now just looking at what a protocol is and why protocols are needed. So let's, for instance, consider how we communicate or access web pages. We could be sending emails or accessing websites using a range of different devices, from a smartphone to a laptop computer to a desktop computer on an Apple Mac to an Android phone. So here we have at least 4 different devices. We have an iPhone we might be using to access the internet. We have a Windows-based laptop, an Apple PC, and we have an Android-based mobile phone. And all these devices use different hardware, run different operating systems, use different software. So the question is, how can these devices all communicate and share data if they're designed and built by different manufacturers? Well, the answer is that we have protocols. And a protocol is a set of rules that all devices use to facilitate communication. And without these protocols, devices from different companies using different software and hardware would not be able to communicate with each other. It would be a bit like arriving in a town and not being able to speak the local language, or indeed having to speak lots of different languages to be able to make yourself understood. What we need is one common language that all these devices can communicate in, and that's specified by the protocol. So the protocol is the set of rules that allow devices to communicate with each other. There are lots of different protocols. These are some of the most common protocols that are used on the internet. The first protocol here is the TCP/IP protocol, and this is the actual protocol that the internet uses. The internet is based upon the TCP/IP protocol. The next protocol we've got here is HTTP, or Hypertext Transfer Protocol, and this is the protocol that is used by all web pages. There's a variant of HTTP, which is HTTPS. This is the protocol that's used to send data securely between websites. POP3 is a protocol used to download emails, and POP3, once an email has been downloaded, will delete the email from the server. SMTP is a protocol used to send emails, and IMAP is a protocol used to download emails. But unlike POP3, IMAP will keep the emails on the server. And finally, there's a protocol called FTP, or File Transfer Protocol. And FTP is used to upload or download files across the internet. Don't worry if you can't remember all of these protocols. At this stage, it's important that you simply know what a protocol is. And we will look in a bit more detail on some of these protocols on the next couple of slides. So, what's the difference between HTTP and HTTPS? Well, HTTP is the Hypertext Transfer Protocol, and HTTPS is the Hypertext Transfer Protocol Secure. But what does this actually mean? Well, both these protocols, HTTP and HTTPS, are used to access web pages. HTTP simply sends plain text when accessing data and sending it between your machine and the web server. So for instance, if you were logging into a website using HTTP and you were to type in the password ABC123, that is literally what would be sent from your machine to the web server. And anybody intercepting that data would be able to see that you were sending as your password the text ABC123. This obviously is not ideal. We don't want people intercepting the data that you're sending between your computer and websites, particularly if it's password data, and also particularly if it's credit card data. So HTTP is no good if we're sending sensitive data that we need to keep secret. Instead, what we use is the HTTPS protocol, the S standing for secure. And if we're using the HTTPS protocol, then what happens to that password ABC123 before it is sent is it's encrypted. It's turned into what looks like gibberish. So in this case, the hacker would simply see what looks like a random series of letters. They wouldn't be able to see the password that you've typed in because we're using HTTPS and the data is encrypted before it is sent. So HTTPS encrypts the data before it's sent, keeping any personal data such as passwords or credit card or bank details safe and secure. And the way you can typically tell that a website is using HTTPS is to look at the address bar in your web browser, and you'll normally see a closed padlock symbol to indicate that this is a secure connection. Okay, one of the other protocols that we introduced on the previous slide was POP3 and IMAP. And it's worth spending a little bit of time considering the difference between these protocols, because both these protocols are used to download emails, but they work in two different ways. POP3 is what we call a post office protocol, and IMAP is Internet Message Access Protocol. Now let's suppose that we're sat at a computer and we want to access our new emails. Our computer would need to create a connection to an email server. a special machine on the internet somewhere that stores and receives all of our email data. So we'll create a connection to that email server and we'll request our new emails. The email server will process this request and will send back to us those new emails so that we can download and view them. If we're downloading our emails using the POP protocol, then once we've downloaded the new emails, those emails then get deleted from the server, and this would free up space on the server. This is what's called POP3. So we download the emails using POP3, and then the new emails get deleted from the server once they've been downloaded, thus freeing up space on the server. The only problem with this method is that suppose we're accessing our emails from multiple devices. So instead of just accessing our emails on a desktop computer, we occasionally log onto a laptop or a tablet or a mobile phone and want to download our emails. If our emails are deleted from the server, then we won't be able to access any of those new emails that we've downloaded onto our PC on our tablet computer. Because when they were downloaded to the PC, they were then deleted because we used POP3 from the actual email server. To overcome this problem, we can use the IMAP protocol. And the IMAP protocol makes sure that the emails are not deleted from the server once they're downloaded. And IMAP allows us to access our emails from multiple devices. So another good opportunity to have just another pause for thought. Can you name some of the protocols? Can you state what some of the protocols are used for? Can you explain the difference between HTTP and HTTPS? And can you explain the difference between POP3 and IMAP? If not, don't worry. Go back, have a look at some of the previous slides in this video and make sure that you've got your head around the differences between these different protocols. So this concludes this lesson on protocols and domain name servers. Before you finish this video, do make sure that you can explain what an IP address is and what a domain name is. That you can explain the role of a DNS and how a DNS is used to access web pages, and make sure that you can name and describe some of the common protocols that we've looked at. If you can't do any of these things, then as always, go back in the video and re-watch some of the content. It's perfectly okay to not understand something straight away, so long as you recognize you don't understand it, and go back and make another attempt at trying to watch parts of this video again. Maybe even making notes, or getting a friend or a member of your family to test you on some of the keywords and some of the concepts in this video. What's important is that you don't give up. Do make sure you've mastered this content before you attempt the quiz.